Hi, and welcome to 3.1 Dividing Fractions from Course 1A Singapore Math. This is a content video that we always do before we do independent practice. So let's understand what is this chapter all about. As you can see, this chapter has four things to understand. So let's get started with the first part. It says divide a whole number by a proper fraction. It's a whole number that has to be divided by a proper fraction. Now there are two ways to do it. One is a bar model and one is regular calculation. So I will show both the methods. So whichever method is asked, you can use that method. As you get bigger numbers, using regular calculations will be much easier compared to bar model. But let's understand both the methods here. So we start with bar model. Let's say, for example, the whole number is 5, which needs to be divided by 2 upon 3, a proper fraction, right? So this 5 needs to be divided. So we make 5 bars here. 1, that's 2, that's 3. I know I'm not using the ruler, they're not equal, but we usually make them equal, right? That's the fourth one, and that's the fifth one here. Now, this number here, 3, tells me that each bar needs to be divided into 3 parts. Okay, so let's understand how each number here guides us to make our bar model. So 5 here told us that we need 5 bars because that has to be divided. Now this 3 tells us that each bar needs to be divided into 3 parts. So we do 3 parts, right? This is how we make 3 parts. Okay, now remember, because you have this line and this line already done, if you have to divide into 3 parts, you will make 2 lines as I did. If you have to make 10 parts, you will have to make 9 lines. Okay, the number of lines will be 1 less than the number of parts that you have to make because the side lines are already there. Now what does this 2 tell me? It tells me how many of it will make 1. Okay, so how many of it, like from 3, how many parts you have to take to make it one whole? So it's 2 parts. So this 1 and 2, so that's 1 part. Let's make it 1 here. Then this one here, 2 again, so that's 2 parts. That's again 1 and 2, that's 3 parts. Then we have this again, 4. This again here, 5. We still have 1 left, right? And we can combine them. So this one and this here together, that's 2 parts. So that's the 6th one. This and this here together, that's the 7th. And this last here, we cannot combine. That's just left alone here. Okay, because we need 2 parts to make one whole, right? So we have only 7 possible parts here. So we say it's 7, and then we'll have to take care of this 1. So what is left? How many parts are left? 1. So we write that 1 over here. Okay, the parts that are left we write there, and then upon 2, because this is how many we need to make one whole, right? To complete one whole we need 2 parts. So the answer is 7.5. So how did you get 7? By actually doing this process here, right? Like taking 2 parts and counting them. Like 1 there, 2nd here, 3rd there. This was 4, this was 5th. This together made 6 and this made 7. And now we are left with only 1. So 7 whole parts can be done. So we write 7 here. Then 1 is left. So we write 1 here. And we needed 2 to complete each, right? So we write 2 there. So that's how you do bar model. Okay, now let's see how regular calculation would be done for this part. So we write 5 as it is. Division is here. This division will become multiplication. Okay, and this fraction inverses. So that is 3 upon 2. That's how you inverse. By inverse, numerator becomes denominator and denominator becomes numerator. Okay, So now we do these calculations. 5 times 3 is 15. Denominator as it is, as there is no multiplication. So if you divide this, you will still get the same answer. 15 divided by 2. 2 times 7 is 14. 1 remainder. So the quotient is here, 7. This remainder comes here and the divisor comes here. So it's the same answer. So these are two methods, bar model and regular calculation, to get the answer. Both are easy methods. Of course, this goes faster and it's convenient for larger numbers. But if you are asked to do bar model, you will have to do, and it's there in independent practice. There are questions specifically mentioning use bar model. So you have to understand both the methods and practice both the methods. Now let's go to the next topic here. It says divide a proper fraction by a unit fraction. Proper fraction meaning numerator is smaller than denominator, like 2 upon 3 here was a proper fraction. This is not a proper fraction. It's called improper fraction because your numerator is greater than denominator. And by unit fraction, it means your numerator will have 1. Okay, so let's take an example of 3 by 4 divided with 1 by 8. Okay, let's use pizza as an example. So we make a circle here and 4 parts, right? This has 4 parts. Now 3/4 of it. So where is 3/4 here? 1, 2 and 3. That's the 3/4. So then it says divide by 1/8. So this whole pizza needs to be divided into 8 parts. So let's make another pizza here. And we divide into 8 parts now. Okay, not 4 parts, it's 8 parts, right? Let me put the division sign here. In this 3/4 that you have, how many 1/8 parts can you have? So we have only 3/4, right? So this is what we are going to consider from here up to here, because this 1/4, we don't have it. We have only 3/4 pizza, right? So how many parts do we have? Let's count. We have 1, 2, 3, 4, 5, and 6. So the answer to this is 6. So this is how bar model can be used. You could have done regular bar model like this also, but I just used a different reference. Okay, so this is how you divide a proper fraction by a unit fraction. And let's see how we would do this if we have to do normal calculations without bar model. So we write the first fraction as it is. This division will become multiplication and this fraction will be inversed. So we say 8 upon 1, right? So division becomes multiplication and the second fraction inverses, not the first one. Now here we know 8 times 1 and 8 times 2. We take the common factors out. What are we left with in numerator? 3 and 2. 3 times 2 is 6. In the denominator we have 1 times 1. We don't need to write that. So it's 6. Both the methods are here for your reference. Bar model or calculation. As we did with this one, bar model works with smaller number, but with larger number, this becomes much easier and convenient to do. It saves time. You go faster, right? So choice is yours. But if it's mentioned that you have to use bar model, then you have to. So these are the two parts. Let's understand next two parts that we have here. Divide a proper fraction by a proper fraction now. So we have to divide proper fraction with proper, which means the numerator is smaller than the denominator. So we will do that part here. So let's take again an example of a pizza. Let's say our pizza is here and it's divided into 7 parts. Because I'm doing it now, my division will not be exact. So bear with me, but I'll try and make 7 parts here. 1, 2, 3, 4, 5, 6, and 7. I know they're not equal, but we need to make them equal, okay? So we have 6th, 7th, right? So the dots that we have 1, 2, 3, 4, 5, and 6. That's the pizza. And then we say that each person gets 2/7 of the pizza. Per person we have 2/7, which means two parts will go to each person, right? So if we count that, how much do we have? This together will be one part, right? Because 2/7, two parts have to go. Then this together makes the second part, and this together makes the third part. So the answer for this is 3. 3 people will get that pizza. Okay, so this is how you do using bar model. Now let's do the calculations here. So we say 6/7 of the pizza needs to be divided into 2/7, right? 6/7 is the total here, and we are dividing it by how much? 2/7. So that's what we write here, and the process remains the same. First fraction as it is, we don't change that. Division becomes multiplication, and we inverse the second fraction, so that's 7 upon 2. Now we know that 7 will be cancelled, right? 1 and 1. 2 times 1, 2 times 3. What are we left with? In the numerator we have 3 times 1, that's 3. In the denominator we have 1 times 1, we don't need to write, so that's 3. So both the methods again, bar model or calculation. Good? Now let's go to the last part. And the last part says divide a fraction by an improper fraction or a mixed number. Okay? Improper fraction or a mixed number. Improper meaning numerator is larger than the denominator. And mixed numbers, we have already seen here, like the 7.5 here. This is a mixed number. Okay? So let's practice doing that. Let's say we have 7 upon 9, a fraction, divided by a mixed number. Let's say 3/1/4. First thing we need to do is convert this mixed number into a fraction, and it's going to be an improper fraction. Okay, so we do it here. 3/1/4. This needs to be multiplied and this needs to be added. So we say 3 times 4, this multiplication, plus 1. This one is added, divided by 4. So that is equal to 3 times 4 is 12. This will be 12 plus 1 is 13 and upon 4. So it has become an improper fraction now. Okay. I purposely took mixed number because with mixed number directly you can't. You have to convert into improper, and we have improper and mixed here, right? So you know from mixed you'll have to go to improper, and we solve from there. So now we are into improper. So whatever we do, if improper fraction was given, that's exactly how you would do. If you have a mixed number, this is one extra step that you need to do. So we rewrite this question here again, which is 7 upon 9 divided by, we don't write a mixed number 3/1/4. We will write this here improper that we have. That's 13 upon 4. So we do 7 upon 9, division becomes multiplication, and we say 4 upon 13, right? We inverse this. Now we don't see any common factors here. So we simply multiply. 7 times 4 is 28 and 13 times 9 is 117. So this is where we end. Okay, so here we just have calculation, no bar model here. Remember, if you have mixed number, you will first convert into an improper fraction and then rewrite your question. Instead of mixed number, you will have it improper fraction written over there. After that, as you did in other subtopics, the same thing. First fraction as it is, division becomes multiplication, and you inverse the fraction. And then you take out the common terms if there are any. In this case, we didn't have it, so we simply multiplied and we got the answer. So this is how we do it. Okay? And with that, we have done all the 4 subtopics of dividing fractions. I suggest rewatch, get it clear in your head, very clear, And then we shall meet for the independent practice. Until then, keep watching, keep practicing, keep revising, and of course, enjoy too. Goodbye.